Now that we've learned what lemmatizing means, we're going to put it to use. So we'll do this in 2 steps. First, we're going to test out the lemmatizer on specific words to understand how it works, and then we'll apply it on the SMS spam collection dataset to further clean it up. So the same process that we saw in the stemming notebook. Just like we saw with stemmers, there are a few different lemmatizers as well that handle words in slightly different ways. So we're going to use the WordNet lemmatizer. This is probably the most popular lemmatizer. So WordNet is a collection of nouns, verbs, adjectives, and adverbs that are grouped together in sets of synonyms, each expressing a distinct concept. So this lemmatizer runs off of this corpus of synonyms. So given a word, it will track that word to its synonyms, and then the distinct concept that that group of words represents. So you can read more about it at the WordNet website right here. So we're going to import the NLTK package, and we'll call the WordNet lemmatizer from that package and store it as WN to be used later. We're also going to call the Porter stemmer again and store that as PS. This is so that we can test out how these 2 methods handle the same words differently. So let's run this cell, and then we'll call the dir function with the WordNet lemmatizer to see what attributes and methods are contained in here. So the one that I'm going to call out is the lemmatize function. This is the one that we'll be using in this lesson, and it's the most commonly used function from this tool. So let's add a cell, and when we looked at stemming, we mentioned in the slides that meanness and meaning were both condensed down to mean. So Python would now assume that meaning and meanness were exactly the same, which is inaccurate. So let's confirm that by printing out the stem from the Porter stemmer, so ps.stem for meanness, and then we'll just copy that down to the second line, and we'll print out meaning. So again, we need the print statements because Jupyter Notebooks will only return the most recent function call. So run that, and it returns mean for both of them. Now let's explore how the lemmatizer might handle these differently. So we'll have to do print again, and this time call the WordNet lemmatizer dot lemmatize meanness for the first one, and then we'll just copy that down to the second line, and we'll replace meanness with meaning. Run that. Also note that this takes a little bit longer than the stemmer. Again, that goes back to because it's not just using a set of simple rules to chop off the suffixes, it's actually tracking it against the synonyms to find what group these fit into. You'll notice that both of these were untouched. So this brings us to an important point, and I'd like to highlight 2 things. First, stemming uses the algorithmic approach, so it's only concerned with the string that it's given, and it'll essentially chop off the suffix. Lemmatizing is a little bit more complex in that it searches the corpus to find related words and condense it down to the core concept. The problem is that if this word isn't in the corpus, then it'll just return the original word. So that's what's happening here. So with that said, not condensing it in this case is probably better than incorrectly stemming it using the Porter stemmer. So that's one example. Let's look at one more example. So let's add another cell, and we're going to copy the stemming down here. And this time we're going to try goose versus geese. These are clearly related. One is just the plural of the other. So let's just run the stemmer on that, and you'll see that the stemmer doesn't quite know what to do here with goose and geese. So it returns 2 different root words. So again, Python will still view goose and geese as 2 different things, even if you use the stemmer. So let's try to use the lemmatizer on goose and geese and see if the lemmatizer is any better at handling these differences. So you'll see that the lemmatizer correctly maps both of these back to goose. Python will be able to now realize that these are the same words. So lemmatizer can be quite powerful in some relatively complex situations. So now that we've learned a little bit about how the lemmatizer works, we're going to do the same thing that we did with the stemmer, where we're going to read in our SMS spam collection data set, clean it up by tokenizing, removing punctuation and stop words, and then we'll apply the WordNet lemmatizer at the end. So now reading in our SMS spam collection data set in the same way that we have the last few lessons and assigning the column names. Let's just print out the first 5 rows just to make sure it's reading in as we expected, and it is. And then just as we saw with the stemming lesson, we're defining our clean text function where we have separate lines for the punctuation, the tokenizing, and removing stop words that we just took from last chapter. And then we apply it to our data set using a lambda function. And again, we'll just print out the first 5 rows just to make sure that it's doing what we expected. And it's removing our tokenized list without stop words or punctuation. So let's jump into the lemmatizing portion of this. We saw before that wn.lemmatize is what applies the lemmatizer for each word. The field that we'll be working with is a list of words in body, text, no stop. And so we're going to do exactly what we did in the stemming lesson by using list comprehension to iterate through the list of tokens and then return the lemmatized version. So let's define our function that we'll call lemmatizing, and I'll expect to be passed in a tokenized list of text. And then we'll define our list comprehension in the same way that we have in the last few lessons. So word for word in tokenized text. And again, we'll assign this to text. Just like we did in the stemming exercise, we'll just apply our lemmatizer here so that it returns the lemmatized version of the word instead of the original word. And then we'll tell this function to return that text. And lastly, we'll use a lambda function to clean our data set. So we'll tell it that we want to store the cleaned up version in body text lemmatized. And then we want to apply this on body text no stop. And we'll apply this using a lambda function, lambda x, lemmatizing x. And then let's go ahead and print out the first 10 rows. So we have this new cleaned up column, and I'll call your attention to a couple of things. Just like the stemmer, the lemmatizer won't do particularly well with slang or abbreviations. So it's not ideal for this data set. It might be much more effective if it was used on a collection of book reports or journal articles. So I will call your attention to a couple things that the lemmatizer was able to impact. So it transitioned this lives down into life, and it also transitioned mobiles into mobile. And so you'll notice that these aren't super interesting examples necessarily, but as you saw above, the lemmatizer can do some relatively sophisticated things, at least more sophisticated than the stemmer. So now you've learned what lemmatizing is and how to actually apply it. So both stemming and lemmatizing helps us reduce the corpus of words that the model's exposed to, and it explicitly correlates words with similar meaning. The lemmatizer is typically more accurate than the stemmer, but the trade-off is that it takes a little bit longer to run. So based on your machine learning pipeline, if the lemmatizer is going to be a bottleneck, then you may opt for the more simple stemmer. So these lessons were very much geared towards just introducing you to the tools and learning the extreme basics to apply it. I encourage you to dig in further to learn more about these tools.